topic 7.11 for AP Chemistry, Introduction to Solubility Equilibrium. The learning objective is to be able to calculate the solubility of a salt based on the value of K sub Sp for the salt. Another thing that we can use equilibrium for is to look at the solubility of solids. So we have some that are partially soluble, not necessarily completely soluble or insoluble, but some that partially does, but not really. So when you're doing dissolution or we're dealing with solubility like this, it is a reversible process. The solid and aqueous ions are back and forth in their equilibrium. So remember, that's a dynamic equilibrium. To denote this, we use something called K sub Sp. Sp stands for the solubility product. So you always write this as a solid going into its aqueous ions. So solid to aqueous, whatever that is. Since we're dealing with solids and liquids, those cannot be involved in your K expression. So that means that for this, there's no solubility, there's no, there's no denominator for the way that this is written out because they're solids. Okay? So we can look at a few types of questions that are going to use some type of solubility, equilibrium, etc. So you can find the solubility. So for example, if the KSP for lead 2 chloride is 1.7 times 10 to the minus 5, you can kind of set that value to the expression. So we're looking here, how do we have to represent the amount of lead 2 chloride that can dissolve. So we are going to look at our balanced equation and see that we have the mole ratio 1, 1, 2. So since we're only focused on this part right here, in our expression, it's only going to be the lead ions and times the chloride ions squared. Since we're dealing with solubility, we can set that equal to, set each of these as S. So it will be, so S times 2S because of the moles in the front, but also you still have to square it in the end. So 4S cubed, that's what all that equals. You cube root it, or I don't know what the word is. You decube it or cube root it to find your answer for the X. So that means that for this, the concentration of lead 2 ions is 0.016 molar, and chloride ions is 0.032 molar because it's times 2 of that. Alternatively, you can find the KSP given the solubility. So you have your compound dissolved in water, and they found out the molarity is this value here. What is the KSP for AB3 for this? So you set your KSP equal to the expression. So it's A3 plus times B minus cubed. To get this, remember that it's S times 3S then cubed out there. You do the math, you end up with your K sub Sp. Because different compounds have different ratios of ions, you can't compare unless they form compounds in the same ratio. Compound XBr3 has a KSP value of 4.52 times 10 to the negative 8, and KBr3 is added to water. What is the concentration of its ion? So remember that all of these are considered water soluble at some point, whether these are going to be partially soluble. So XBr3 is a solid. It dissociates into X3 plus ions and 3 Br ions. because of the ratio from the you get from the formula. So kind of like before, this is S. We'll make this equal to S, S, and then because of the three BRs, it's 3S. So KSP will equal X3 plus times BR cubed, which equals S times 3S cubed. That will equal 4.5 times 10 to the negative 8. So now I'm going to solve to get the S, and from there that I can get the concentrations. So this is going to be 27 to the fourth, so 27S4 to the fourth, I guess, equals 4.52 times 10 to the negative 8. You do your math, you end up with S equaling 0.0064 M. So the two, just so you know, the 2 sig figs comes from here. So my concentration of X3 plus equals 0.000064 molar, and my concentration of Br will be 0.019 molar. Will a precipitate form if 120 mLs of 0.100 magnesium nitrate, molar of magnesium nitrate, is added to 440 mLs of 0.00450 molar sodium hydroxide. The KSP for magnesium hydroxide is listed right here. So it tells you what's going to be involved in this. So you have two aqueous solutions being mixed. This is going to be you're going to end up having a double displacement reaction where this is going to be the precipitate that forms. The sodium ions and the nitrate ions are spectators, so they're not involved. So you got to figure out what is my reaction. So MgOH2 solid produces Mg2 plus aqueous plus O2 OH1 minus aqueous. So my KSP will equal Mg, the concentration of Mg2 plus times OH1 minus squared. What they're asking though is, will a precipitate form? And they give us two concentrations and two amounts essentially. So what we need to do is we need to find the concentrations that's going to be in the solution, because when you add two solutions together, they'll dilute, so you need to find the new concentrations. Then from there, you can solve the problem or go from there. So to do that, first we need to use something called a dilution factor. So for magnesium concentration, which here's what you're going to do. So you're going to take the volume of the magnesium nitrate, the 120 mLs. You're going to put that over the total sum of the new solution. So it's going to be 560.0 mLs. Multiply it by the concentration of the magnesium. That will be 0.0214 molar Mg2 plus. For my hydroxide ions, it will be the other number, 440.0 mLs over 560.0 mLs times the concentration, which is 0.0050 molar. That will equal 0.00354 molar hydroxide ions. Cool, and we're not even done yet. So what you need to do is, this is my equilibrium, but I'm going to use a Q sub SP. So that's kind of like the reaction quotient we had before, something similar. So we're going to take my QSP, and I'm going to plug in my new concentration. So let me see, I'll probably have to erase some of this, but it's okay. I'll erase the top. So Q sub SP equals 0.0214 molar times 0.00354 molar squared. And this equals, I'm going to do my math, it's going to equal 2.68 times 10 to the negative 7. So math-wise, my Q is going to be greater than my K, like way greater, obviously. So what it's asking is, will it precipitate form? So if my Q for these concentrations is greater than the KSP for this particular compound, if the Q is greater than the K, that means a precipitate will form. So I could say Q is greater, so you get to put your calculations to prove it, and you would say Q is greater than K, therefore a precipitate will form. That's my final answer. So you have any questions, please let me know. Thanks.